Hello, 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 hello. 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 All right, let's try that. Ah, finally. Thank you. Should have checked this chat a lot sooner, huh? All right. Sweet. So, welcome back to the channel. Sorry about that. This is the first take, obviously. We did it right from the beginning. Yeah, welcome back to the channel. Today's going to be a little bit of a different day. I don't currently have any projects that you guys have sent me to look at, and I haven't been on Reddit looking for stuff. And there's something more pressing that I need to do, which is to set up the brand new printer that we got. Thank you guys for telling me that my audio is muted. Right, so we've got a brand new printer to set up, so it's kind of going to be a hangout stream. If you guys got projects that you guys want me to look at, by all means, send them to me, raise a hand. We can do anything you guys want. I've got SolidWorks and everything set up, so that should be good to go. The printer that we're building today is going to be an Ender 3 Max Neo. So I ordered this maybe, I don't know, 2 weeks ago, and I'm finally getting around to setting it up. I needed something that was a 300 millimeter build plate volume for a project that we're working on. We're trying to do some prototypes in-house. Usually we've been shopping it out. So this is kind of like a new functionality. I've never set one of these up before. But that should be fun to watch me struggle with. And you guys can learn along with my mistakes or learn what not to do. Right, so it's a Ender 3 Max and Neo. The other printers that I looked at were a Elegoo Neptune. Those seemed really nice, but they weren't available in the time frame that we wanted. So basically, they were out of stock everywhere that we looked. And then Bamboo Labs looked at theirs, but they don't have a large enough build plate volume. And the other contender that we were looking at was, or I guess not looking at the time, but which we could have gotten, was Ender just announced new K1 and K1 Max printers that look pretty slick. And so those would have been awesome, but I had ordered this before those were announced. So instead of getting one of those, we've got this to build today. So maybe this will get torn down and replaced, or maybe get relegated to something else in the future. But for now, it's what we have, so it's what we're going to build. The other printer that we looked at, or that I wish I would have known about sooner, was Ender has a direct drive version of this printer, basically. It's like a Pro or something like that. I don't know, their names are kind of screwy. But they have a direct drive version. I didn't know about that, and so I bought the Sprite direct drive extruder for this model, and so we're going to try to retrofit that as well. I don't know if we'll get to that tonight. Maybe we'll just get this thing up and printing with the regular extruder that it comes with. But yeah, so that is the mission of the night. Also, great news, like huge news. Should have probably started with this, but we passed 1,000 subscribers on YouTube, which is absolutely insane, and I never thought we'd get there, and that's just really cool. So thank you guys for all of your support there. Thank you for subscribing. If you're not subscribed, please hit the button. Yeah, for all 1,000 and almost 1,100 of you that have subscribed, I greatly appreciate it. It means a lot, both emotionally and yeah, it's cool to just see you guys appreciate the content that we're doing. And hopefully it's been entertaining and useful to you guys. So it's a lot of fun to make. I've been crushed by client work lately, pulling all-nighters and all kinds of good stuff. So that is both a great thing, a great problem to have, but it kind of makes the YouTube thing a little bit hard to do, hard to make time for. So you got to pay the bills first. Maybe one day this will pay the bills, but we'll get there. So for now, yeah, we'll just hang out. If you guys got stuff to you want me to work on, if you want, feel free to ask questions about SolidWorks or scanning or printing or any of the things that we cover. Definitely, if you got a specific question you want to ask or a project you want to send me, have SolidWorks, we can open it up and look at it and we can walk through it. But yeah, until then, just hang out, and I hope you guys enjoy the stream. And thanks for hanging out tonight. We'll start by opening some boxes and see what we got. So first up is the project that we're going to be doing is going to be an outside project, or the parts are going to be end use outside, right? And so originally the client was looking to injection mold, but they have a very tight time deadline. which means that we basically don't have time to go to tooling, to go through tooling validation and the entire injection molded process. And they only really need about 35 units up front to meet their deadline. So what we're going to do is we're going to injection mold and use parts for them. And because they're going to be outdoor products, that basically means we got three materials that we can come down to. So we got ASA, PETG, and polycarbonate. And so we're probably going to go with PETG, but what I ordered was ASA. And so this is Polymaker ASA. Show you, we can focus. So this is their green. We also have the gray. And there should be an orange kicking around here too, because you gotta stay on brand and have the orange. Yeah, ASA is supposed to be really, sorry if the opening the boxes is like the opposite of ASMR. And this is the orange that we got. Focus. So the ASA is supposed to be really good for outdoor products from what I've been told or from what I've researched. Basically, the UV resistance is supposed to be really good on this, and also the water absorption, because it's going to be out in the elements. Not only that, it's also going to be on a boat. So water exposure is also going to be a thing. So we'll see how the ASA stands up. I haven't, we need to actually print these so that we can do some durability tests in real world and see how they stand up. I currently have a PETG sample sitting out on the back deck of the office, getting some sun exposure and rain and basically the elements. So we're just kind of playing with that to see how that holds up and survives. But ASA is going to be the first priority, I think, or the first choice. So we'll see what happens. This is Polymaker stuff. Not sponsored or anything, just found it on Amazon. They delivered pretty quick. They had a lot of colors available. And from what I can tell, it doesn't seem to be a bad brand. So we'll see what happens. We'll see if it's difficult to print. I have a little bit of concern. The printer that we have doesn't have an enclosure, so I don't know if it's going to have some issues with that. But we're going to play around with it and see if we can get it to actually print. Let's see here. So this is the Creality Sprite extruder. Again, none of this is sponsored. This is all stuff that I purchased with my own money because it seemed like it was good stuff. So this is a direct drive modification for the Crealities. Excuse me. So this is a direct drive modification. Basically, there's two different types of printing extruders, main types, I guess. One is a direct drive where basically the filament comes in the top of the extruder. This is all for FDM, obviously, right? So like SLA is different, but for FDM, there's two types of extruders. The direct drive one, which is this modification, basically has the gears right above the melt zone. And so there's a very small distance between where the filament is being forced from and where it's actually coming out of the nozzle. And this allows you to have a little bit better control over basically what's coming out of the nozzle because the distance is so short. The other version is, I can't remember what the name of the tube system is, but it's a longer tube system where it basically has the extrusion, the gears that drive the filament are located somewhere off of the head that's going back and forth and printing. This lightens up the mass of the head a lot, but it creates a larger distance where the filament is being fed through the tube to the head. And so because the filament's going through a tube, I ask what your design process is and how you work within constraints. Absolutely. If you mind, like, just specifying what your specific questions would be, I'd be happy to answer it as soon as I done with this little bit explaining the heads. So basically there's a tube that the filament goes through between the extruder head where the gears are and the nozzle that's going back and forth. And because there's a larger distance there, there's basically a delay and there's slop in that connection. And so it's not as well controlled as with a direct drive. So direct drive is a little bit more, little better control over what you're doing, whereas the other one is not so much. As far as printing ASA inside of a tent, I know I saw tricks, or I saw people doing that trick of basically doing a camera tent or a cardboard box, or like Reality sells a big like insulated chamber. There's a couple other companies that make those too. I don't know if we'll have that issue or not. I haven't bought one yet. Like I said, I ordered this about 2 weeks ago. Haven't gotten time to set it up because of work stuff or because of client stuff. And so I don't know if we're going to have an issue printing the ASA or not. If we do, that's definitely something that I would look to pick up. If I have too much of a problem with it, I might just buy a different printer. Now that I know, like retrofitting this, when I asked Reality if this would fit on, they said, well, not officially, but there's people online that have done it. So if I kind of want a direct drive head and I kind of want an enclosure, the new K1s that came out, if I can get a max one of those, it'd be sweet. But that's kind of what it is, I guess. I pulled the trigger when I thought I knew what I was doing, and then learned more information. So sometimes you gotta go with what you got and figure it out later. So yeah, possibly the enclosure would fix that. I guess the main problem is that the bed gets hot and the nozzle is hot, but all the material in between cools and shrinks, and so that can basically like pull the layers of the part apart, and it can cause the edges to like peel up off of the build plate and stuff like that. So we'll see. All right, so Jacob has a question. I think it's Jacob, could be Jacob. Yeah, so Jacob is asking, what is your design process and how do you work within constraints? Specifically, he's looking for how do I avoid scope creep? So the way that I work, for those of you that are unfamiliar with what I do, so I am an engineering consultant, basically a gun for hire. I've worked on, over 100 projects now within Forge and dozens more before I started doing Forge. As far as scope creep, it's if a client comes to me and says, I want to do this thing, right? And as we're working on it, they keep adding things on. I'm in a unique situation where I don't have to answer to anybody else but that client. And if they're adding on the work, it's usually very clear that they're adding something on. And so then that just becomes like a line of communication that needs to be had, right? I write down or I create project estimates and written project specs up front of like, hey, this is what you've asked for. This is what we're going to deliver. This is the timeline. This is the pricing, all that stuff, right? But I always go into that and deliver it as an estimate, because sometimes you learn things along the way that causes scope creep or time delays or additional funds, or all of the things that project managers deal with and that you guys have probably dealt with on your own projects. But I think the only way to really deal with it, scope creep in particular, I suppose, is to communicate directly with whoever the client is, and that can be your boss or your manager or your boss's boss or somebody like that. But I think in terms of scope creep, you have to communicate what is causing the creep, and the best way to do that is to document what was requested up front. So if you know what was documented up front and they say, yes, we want this thing, and then they go to add additional things compared to what that spec is, then you can say, okay, well, that's scope creep. This is going to have additional cost, time, whatever the thing is that it's causing. But I think just clearly communicating this as like, hey, this is just the facts of the situation. There's nothing to get upset with. I think that goes a long way. Like if we have a project, like I said, everything we do is an estimate, right? So if we have a project that things come up, like we have a project to working on right now. We need to add an entire giant assembly to it that's got 100, 200 parts. That's additional work that needed to be done, and it was really just communicating with the client, hey, this is something that's come up. Neither one of us knew about it beforehand, so we couldn't have estimated that was going to happen. It's going to cause the estimate to go up. So I hope that helps. I might need to pause to get a water here in a minute. My throat's going to dry out. Does that help answer your question, Jacob? Again, if you got follow-up questions, I'm here all night, so, or at least for the next hour and 10 minutes. Next up, so speaking of build plates, are we still good? It looks like the video may have paused. So this is a magnetic build plate with a PEI sheet. Basically, this will allow us to print onto here, and then instead of having to chisel off the part from a glass build plate that isn't able to flex, you basically just bend the build plate and it'll come right off. So it looks like there's two different, one side looks like it's coated, and then one side looks like it's just plain. And then this is the magnet that will attach to, it's just 3M magnet that will attach to the bed. And then this plate will go on top like that, and then it'll print, the printer will print on here. Like I said, I haven't set one of these up before. About, I don't know, 15 years ago, I was working on a printer. The first one I ever saw was actually outside of college when I got my first professional job. It was a printer that was probably the size of, I don't know, if you stacked like two microwaves on top of each other. It was about that size, had a big oven door that you would lift up, and a tiny little build plate that was maybe about that big. And we were doing it to prototype injection molded pieces. And it worked really well for that. It was supposed to be a dissolvable solvent, so it printed in two different materials, and that solvent never dissolved. So basically, I would end up using pliers and chisels and picks and whatnot to try to free my parts from this terrible black support material that never dissolved. But it was really cool back in the day. Geez. Like I'm old. It was really cool because this is the first time I had ever worked with the technology, and as far as prototyping, I mean, we were able to do CAD and then have it in our hands in the next day or two. I mean, that was unbelievable to let it run overnight. So that was pretty cool. The whole thing was in a big, it basically looked like it was an insulated oven. So I have to imagine that is part of the reason why the build plate was so small and the technology was just probably still pretty new. Now we have open head ones, and they don't always need an oven, and this probably has a lot to do with the advances in materials as well. So it's a little bit of my background with printing. So let's see what this is. Okay, so this is the Ender series filament that they sent. So this came with the, doesn't say what color it is. This came, it's just like a tan color. Like natural. But so this came with the printer as part of the package. So this is just 1,000. Yeah, this is a kilogram of, I guess, whatever they had lying around. I'm not even sure what material this is. Oh, so this is PLA. So this is Ender PLA. So we'll probably do the setup with this, the non-production, the non-ASA stuff. So we'll see what that does. Cool, just checking the video. It looked like we were paused for a second, but I think we're good now. Cool. All right, so the last box is the actual printer, and I don't know how I'm going to be able to get it over here or show you guys what it is, but I guess we will see. All right, here we go. So this is where it's supposed to live. This thing is absolutely. So the first thing out of the box is more material. So this is Ultra PLA. That doesn't seem right. Yeah, so this is PLA white. So this is white, and then it looks like I've got the other box was a natural color. Let's see what's in these little packages. Oh yeah, no, absolutely. Well, we can do CAD review right now. I don't know if you were here when I started the stream, but basically I have to build this printer at some point, and so we're kind of just doing it as a live stream. But like I said, if you have CAD that you want to send me, absolutely send it to me, and we can open up and look right now. So I'll send. So this is. I'm going to put the email in the chat. So that's the best email to send it to. And then just let me know when you've sent it, and I'll get in and open it up, and we can take a look at it. Oh, so these are nozzles. So it came with a nozzle pack. I don't know if you guys can see that or not. Come on, camera, focus. So it's a whole bunch of different nozzles. I'm hoping that they're different sizes. The parts that we're printing are really big. So it'd be nice to get a large size nozzle. Again, this was just something that was in, like, when I ordered from Creality, it was something that was just included. But it said assorted nozzles. It didn't actually specify what sizes we got. All right, so we got a 0.4, a 0.3, a 0.2, a 0.5, and a 0.6. I don't know if you guys can see these, but so this is the nozzle. This is where the actual filament comes out. It goes in this side and comes out the small side. And there's a tiny little hole. I don't know if you can see it, but there's a tiny little hole in there. And the 0.6, 0.4 that I was reading out is laser engraved on the side. And that's basically how big that hole is. So it's the units is millimeters. But different sizes obviously put out different amounts of material. So the larger the number, the larger the diameter of the hole, the larger the more material you can put out at one time. Excuse me. The more material you can put out at one time. And so the faster you can print, but you lose fidelity because your layers then become a little bit thicker. And basically the filament that's coming out, the actual bead is thicker. And so you lose fidelity in your models. So I can neck it down and be really accurate and have fine detail, or I can neck it, or I can go up in size and print faster. But it's kind of trying to find that balance. All right, right here. That's the last thing in this little box. And we'll go back to the big box. Yeah, I downloaded both. I have Prussia and I think I have I looked at Cura too. I think I'm gonna go with Prussia. It looked like it had like I'm sure they all have the same options, but it looked like it was slightly more user friendly. I could be wrong. We'll find out. Okay, so this is the high temp tubing. So I saw online that a lot of people were recommending this for doing high temperature materials. And that was before I looked at the Sprite extruder. So you can kind of see how like this was multiple orders over the course of a week. Ordered the printer, then ordered the tubing, then ordered the direct drive head. And now I kind of wish I almost ordered a different printer, but we got what we got. As far as the 0.6 millimeter that's being recommended, that makes sense. I can't show the print because it's proprietary. But I mean, it's a big print, right? I needed the 300 by 300 because I actually had to squish the part slightly to get it to fit in the build volume. So that's going to be pretty big. And so they don't really, the client doesn't really need fidelity so much as just the parts to work. And so we're probably going to go with a big nozzle. I was looking at like a 1.2 or something like that. I don't know, the layer lines might just look cool at that size and that big scale. I don't know. But so we'll probably have to play around with that as well. It's definitely not going to be a 0.4. 0.6 sounds good. I was looking at 0.8s and 1s and 1.2, and then there's the nozzles that have like basically the mixing chamber, and they're not mixing chamber. I don't know, it's like fins that go in the middle of it. Basically, they drilled 3 ports that all kind of meet up right before it comes out. And so that allows you to, I guess, flow a lot more material because it just melts better. It's got more surface area to melt. So that was pretty cool to see and look into. So I might get one of those as we get going. Yeah, I feel like it's kind of like you buy one part of this thing and then you're like, oh, and then you can do this and then you can do this, right? It's like buying a car or like a nice race car or something. You're like, but you could put a turbo on it and a supercharger and some rims and better brakes. And so they just nickel and dime you once they start. They should give the printers away for free. All right, next thing out of the box. Now let me know if you sent that CAD package. All right, so this is the holder for the filament. That part, at least I can recognize it now. Organize my workstation here a little bit. All right, cool. Let's take a look at Mom's file real quick. Sorry for the downtime as I open everything up. Get SolidWorks open. So waiting to see if it's come through now. There we go. You did master modeling. That's awesome. Good for you, man. So this is, Nam, I don't know if you want to give us more background on what this is. So it's for your robotics team for school. So I'm assuming you're in school right now. All right, that's a pretty big model. All right, cool. Gotcha. So is this part of a like a SolidWorks class, Nam, or is this a or is this just a project that you guys are working on independently? So I'll open the biggest. It's okay to show this, correct? All right, cool. I just don't want to throw something proprietary up on a live YouTube stream. All right, cool. Nice, dude. All right, here we go. Let's take a look at it. All right, cool. All right, so this is your model, right? Okay, looks awesome, man. So it came in lightweight, so we'll set all lightweight to resolved. Also, we have an error here, so I'll have to figure out what that is. This first robotics competition, I think I've helped another school with this actually, or another team maybe. I don't know if you guys happen to be from the same school or not. But is this the one where you have like this year's competition is you have to move cones and stack them up on top of like, I don't know, they're like sticks or something like that. It's timed. All right, so these little hats here just means it's education version. So he built it inside of an education version. And so SolidWorks basically puts this symbol in here and it threw up a warning that I already cleared. Yeah, this looks really good, man. It's cool. Let's try and figure out what our errors are. And it looks like mates are an issue. Was this a pack and go? I'm assuming it was. I'm assuming all of this just came out as a pack and go, and it's probably just some type of reference error or something. It looks like these are all suppressed already, unless SolidWorks suppressed them to try and prevent it. Yeah, so it's missing a face. I might be missing a part. Maybe something that wasn't loaded in. Is there anything specific that you want to look at? Yeah, it's probably just a part that didn't get pulled in the pack and go possibly. So when it gets loaded up, all it is missing. It's just missing that reference part, so the mates are all aired out. Is there anything specific that you want to look at? Oh yeah, look at you guys. All right, cool, 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 cool. This is awesome. This is really well done. Man, you even labeled everything. Look at you. I'm just going through looking at some sketches. Yeah, that's awesome. Yeah, nice work. Good, good, good structure. Everything's labeled, which is great. I'm assuming these are different design iterations that you guys kind of went through. Yeah, looks like this is the layout that you actually went with. It looks like. Yeah, I mean, I think this looks like the way that I would probably structure it, right? Because you have this. Let's see here. Let's look at the structure, right? So you've got this here, and then are you using? How are you getting your solid bodies? How are you getting your sketches into your different part files? Like, how are you importing your geometry? Gotcha. Yeah, as far as master modeling goes, I think it's definitely the right. Like, I saw a post the other day on Reddit in the SolidWorks forums that was basically, should you do top-down modeling as opposed to bottom-up, where you're just dimensioning everything and then you go in and you have to change all dimensions whenever something changes. And I'm definitely a top-down person. I would rather take the extra time. I would rather spend my time building the model to get along with itself. So that when I made changes, they auto updated, as opposed to building dumb models and then spending my time like making sure everything lines up and going and tweaking things. As far as the structure itself, I'm not quite sure. It looks like you're inserting the part. You're inserting a solid body into a part. Let's just open one of these parts real quick. Let's see here. All right, so you've got two. I mean, this is nitpicky, but you've got two of the similar bodies. You got two bodies in a part file, which isn't necessarily bad. In a production environment, you probably want to only have one body in here, because if you think about it, when you go to do a drawing for this, you would only be dimensioning probably one of these, right? Like, you could hide the other body and that wouldn't be the end of the world when you went to do your drawing. But you may be better off, especially if these are, yeah, they look like they're mirrored. So you may be better off like doing one of these and then just using the mirror plane in the middle within the assembly, instead of having two bodies in here, if that makes any sense. So to try and clarify what I'm saying, when you model something, or I prefer when I model something, I only want to try to have one instance of it in my part file. And if I need two of them, then within the assembly, I'll mirror it. Because also that there's a benefit there. When you go to do the BOM, it's going to show it as two of these parts. If you enter this into a drawing file and try to do a BOM, it would just call out one of these, but there'd be two within the part file. So like, little nitpicky thing, but just something to keep in mind as you're going forward. So it looks like you're inserting these in your master model, and then you're pulling sketch information from them. I don't know if this is just missing. I don't see this EVMM in your zip file, so it could be why things are freaking out. There's EVMM and then a bunch of, oh no, here it is. Okay. Let's open this up. So this is saying that there's this arrow is meaning that there's an external reference, but there's a question mark because the link is broken or it's out of context. Okay, so this is that EBMM. Okay, so it looks like you have a, so you're inserting part files into the parts. Is that what you're doing? And then you're pulling your geometry off of that imported part at the top of your tree. Oh yeah. So all your sketches are in here then. Okay, that makes sense. I mean, the one like so this is a different technique than I'm familiar with as far as inserting the part. So what I do, and I don't know if you've watched my video on it, but like when it comes to skeleton sketch, I use derived sketches to import the information. So I'm only importing a sketch using insert derived sketch. This thing here. So as far as how stable this is and how well it's going to work for you in rebuild times, I'm probably not the best person to critique it. But the fact that you're doing top-down modeling is a huge advantage for sure. Have you watched my skeleton sketch video? Gotcha. Okay, cool. So yeah, there's a skeleton sketch. I'll put the link to it in the chat. But I did a video a while back on top-down modeling, and it's the method that I would like if I was going to recommend something to try out. Obviously, this is working, right? You have a very complex model that looks like it's fairly lightweight and fairly stable. It didn't survive the pack and go the greatest, but that could just be because like one of your main part files was missing or something like that. Let's see here. Yeah, so this is the B. So I'm going to put this in the chat. So that would be a good video to watch as far as like seeing how I would do this. Basically what I do is I start everything from an assembly and then I make a part, right? And that part's going to hold all of my sketches that I'm going to share across all the other parts. And so I'm make an assembly, make a part, make a sketch within that, like you have here, like all these mock-up ones, right? All these sketches, so it'd be like these basically. So those would go inside of that one part. And then if I needed to add parts or assemblies within that assembly, so like obviously this whole robot would be my top level assembly, then I'd have a part that holds all my sketches. So then I'd add in those sketches or sub-assemblies, and I would use insert derived sketch to add my sketches from that skeleton sketch part into any other parts that are below it on the tree. So one good thing that you have here, like one of the best things that you can do as far as top down, is to make sure that your tree is building top down when SolidWorks goes to rebuild. And so you want your either skeleton sketch or master model or whatever to be at the top of your tree, which you have. So Like I said, we kind of covered this already. It would be interesting to know what part is missing, I guess, or what caused this to freak out. Like I said, it's only in mates. I wonder if it's all the same face that's missing. So it looks like it's maybe a screw. That 1/2 inch hex something. Yeah. That one looks like it's just missing a screw. Yeah, so maybe it's multiple instances of that screw, like your hardware maybe just didn't come through. It's possible. But as far as overall model structure, I think what you're doing is fine. It's obviously working for you. So I haven't done this version before. It'd be interesting to try the two and compare rebuilds on something similar. And I've talked about that for a while, like doing a video where it's bottom up versus top down using either skeleton sketch with derived sketches or skeleton sketch or like master modeling. Basically, it's the 3 ways to do it. And as far as like rebuilds and stuff like that and model stability. But no, this is very cool. Trying to see if there's anything else that's worth saying about it. Is there anything else that you'd want to cover? Maybe that's something to talk about. So you have this skeleton sketch and this. Okay, yeah, good. Okay, so you're doing that right. So you're inserting the part into the sub assemblies and then inserting it from there. So that's good. Yeah, hopefully I said something intelligent in there. Yeah, I think you're doing it the right way. Did you guys learn this off of a video, or is this what you guys taught and were taught in school? Yeah. Okay. So here's one thing that I'll probably give us feedback. So you have this mirror component, right? And you're mirroring this cable tubing thingy. This this robot is clearly like symmetric across this plane for a majority of parts. So what I would probably recommend doing instead of, I wonder if you have both bodies in the same file again. Yeah. Okay, so that would probably be my biggest I don't know, my biggest tip, I guess, would be like you have 4 of these inside of a single body file. I would just draw one of these, and then within the assembly file, that's where you would, or subassembly, depending on if this is in a subassembly. Yeah, okay, so within this subassembly file, I would use the pattern tools. So like all of these over here, right, that you can use. I would use all of these to create multiple instances of that single body part file, if that makes sense. So when you're drawing something or when you draw a part, you want to draw just that part in there. And then if you use it in more than one location, you want to use your pattern tools or you can just insert it and directly mate it if you want to. But you want to add in multiple instances of that part file. Don't model like how many you need within the part file. Because again, like I said, as you go forward into like building drawings and stuff like that and bills of material, the quantity counts are going to be wrong, and it's going to be difficult to go in and fix that. And also, if you have like a shop floor drawing that calls for one of these things and they open up that drawing, it's going to be confusing that there's 4 of them there. So is it a package of 4? Like they're not always going to be spaced the same in the same positions and whatnot. So that would probably be my biggest takeaway, is model something just once and then use your either your pattern tools or just directly, like you can take this and then just drag it in, right? So you can use control on here if you want to, if there's something already in your tree and you want to add more of it, you can just hold control and drag in, and it'll insert it, multiple instances of it. But say like you wanted to use this part somewhere else now, it'd be really difficult because you have these other 3 bodies in here. So that would probably be my recommendation, like one nugget. That would be useful. All right, cool. Yeah, if anybody has anything else that you want to look at, raise a hand in the chat. Or if you have a specific question that you want to ask, I mean, don't be shy. Close this down. All right, cool. So back to building, I suppose. Yeah, I mean, the fact that you got a mentor to talk you, that's one of the interesting things to me is like when I took CAD, I took class on CAD in college, nobody taught like top down, right? It was like, here are the basic, like, here's the basic commands. And now you've built like, a little block that you can machine. And you never learned like proper detailing of, or like really good detail of like how to build an advanced model. And I guess it's because it's advanced, but nobody even talked about like top down versus bottom up. So you get a lot of people out of school that have no idea that there's even 2 methodologies. And to them, like building relationships that are efficient and update the way that you want between parts is so foreign, that it's really difficult to step into a work environment without knowing those tools and be as productive as you probably should be or need to be to keep up. So. All right, so in the chat, he's saying the way we approach it is having a dot file, having a file for all related parts for the assembly, and then having individual part files for all separated parts for manufacturing. Oh, so you create 2 part files? You're not saving out part like body files into separate part files for manufacturing, right? I mean, you shouldn't. I mean, you don't want to do work twice. So if you have the part file already done, you don't want to make another instance of it somewhere. That creates a revision and control nightmare. I appreciate it. Appreciate the compliment. Trying to do something good. All right, we got a package of tools and looks like a micro SD card maybe or something like that. Flash drive. Power and possibly this goes with our spool holder, I believe. So that kit's out our spool holder. And definitely check out that video that I posted and let me know what you think, because it'd be interesting to compare the two methodologies, I suppose. And like I said, I don't know the master modeling one as well. When I was looking for the methodology that I wanted to do, I found, or I saw both, but kind of chose the sketch one after a brief period of use. And so I don't use it every day, or I don't use the master modeling one where you're inserting the part file into the part file every day, like top down modeling using the skeleton sketch technique that I posted about. That's what I do. Like, I mean, if you send me something, 99% of the time I'm going to build it like that. So that's what I would be able to speak more on. But it would be interesting to compare the two and see if I missed something or if there's advantages from one over the other. All right, so we have control unit. I'm just randomly placing stuff all over my desk. Piece of foam. See if that helps any. Now, can I take it out of here without breaking it? Becomes the question. Looks like it's in two pieces, but already connected together. Cables. So I'm not quite sure how that's supposed to work. Okay. All right, well, it's out. Now it's not bend anything. So the cables are right underneath where I'm pretty sure this thing mounts up. Now that we have it completely unboxed, it's time to read the directions. There you go. Build. Easy as that. All right, let's find some directions. Some swag stickers. User manual. An engineer reading the directions. You thought you'd never see it. Bet this is riveting to watch as well. All right, cool. So basically, we just stand it up, plug it in, bolt it down. No problem. Great to see we didn't need the directions. One of the things that I know is that apparently the lead screws on the back of these things, if they get bent, then you can have issues with print quality. So the entire time I'm holding that thing, I'm trying not to crush those, but also there's not a whole lot to hold on to. And doing it as a solo job is also probably not advised. All right, there's a bunch of parts here that aren't shown in the picture. Ah. All right, cool. So probably not using those for assembly, but at least we have them. All right, 4 screws. They're definitely long enough. Those are definitely long enough. Now they're probably just into aluminum, so it'd be interesting to know what the actual thread count needed to be for whatever the holding force of these are. But still, that's pretty long if it's threaded the entire way, though I doubt it is. So, all right. All right, so now we basically line up the holes and put the screw. Assuming looks like we're doing it the right way. That was just me trying to thread in these giant long screws. I won't bore you with that. I probably got another another 20 minutes. We're going to be live, so if you guys got anything that you guys want to talk about while I'm tightening stuff down, I'll try and put the head on tonight and power it up and see what we do. See if we can crash it on live stream. Yeah, at least we got it standing up. That's pretty good. Could have at least had like music on in the background or something, right? That would have been more intelligent. All right, so everybody put your occupation in the chat while we're waiting for me to tighten these down. What do you guys do? Interesting how much play this has. I mean, you'd think that has to affect the build. But I guess once you lock it down, you calibrate the print head, so probably fine. One screw gets a little bit tight before it's supposed to. Electrical engineers, what are you doing in here? Man, I don't know nothing about EE. Keep the smoke in. That's all I know about electrical. But in all seriousness, it is something that I wish I knew more. Like robotics and stuff like that is just something that I never got into, but wish I knew more of. SolidWorks is fun. What do you do with SolidWorks? So one screw doesn't want to go in. It's got me a little bit concerned. I don't know if it's the threads, the alignment, or the screw. Oh, it makes me hesitant. What are you doing inside of SolidWorks? Mechanical engineering stuff? Oh, yeah, yeah. Did you guys ever get that? Did you guys ever get your molds to work? You guys graduate this spring? You're gonna be on your way out, right? Nice. And I don't even have a 10 millimeter wrench. Never seen one. They don't come in the set. You buy a set, it's already gone. All right, so it looks like this is only tapped at the very beginning, right where this goes in. So for all you mechanical engineers out there that are doing product design, if your threads into your part are only that long, don't put a giant screw in there. All of that additional thread does absolutely nothing. I believe it's either like Confucius or Abraham Lincoln that said only the last turn tightens the screw. Something to think about. Gotcha. Where are you applying to? sweet. Are you going for electrical or mechanical? Let's see here. I know this isn't very interesting, so trying to figure out what the next step is. All right, basically screw it in. Now we got to power it up. This guy hangs off the end. I don't want that to go under there. It's okay, neither have I. I'd actually been interested to know what an electrical engineer thinks of like the SolidWorks tools on that side of the world, because I obviously haven't used them, um, but I know there's tons of plugins for like routings and doing schematics and all that type of stuff. So it would be interesting to know if they're good compared to other tools that are out there for like electrical design, or whether or not they're just kind of like in there as like, oh yeah, it does this too type of thing. So these cables come out right where this pillar comes up, and so basically I'm just trying to figure out if that's where they're supposed to go, or I need to be leaning them back somewhere else. Otherwise the pillar is basically right underneath. These cables come out right underneath the pillar, which I can't imagine is good. They really seem like they want to go in front of the pillar, but they connect in the back of the pillar, so it is what it is. Seems right. All right, guys, I think I'm going to shut it down unless anybody's got any questions. Thank you guys for coming out tonight and hanging out. I'm sorry this back end of things wasn't as interesting, but it was cool to look at some top-down modeling. The next time you see me, this will probably and definitely be up and running. If you guys have any questions or like videos that you guys would like me to make, feel free to either send them in DM or email. I put the email in the link earlier. I appreciate you guys coming out and supporting me and just watching what we're doing. And hopefully you learned something, or and this one maybe specifically what not to do. But yeah, thanks for coming out, and you guys have a good night, and I'll see you in the next video. Appreciate it.